I love riding roller coasters, so I thought it would be fun to show you how to find the potential energy of a rider on a roller coaster and how that turns into kinetic energy. So what is potential energy? Potential energy is the stored energy of an object based on its position. Okay, so what is kinetic energy? Kinetic energy is the energy of motion. An object that has motion, whether it is vertical or horizontal motion, has kinetic energy. How are potential energy and kinetic energy related? As an object begins to move, its potential energy begins to transfer to kinetic energy. How does this relate to a roller coaster in math? When a rider on a roller coaster is at the very top of a hill, they have potential energy. As the rider moves down that hill, their potential energy becomes kinetic energy. And once their height reaches zero, all of their potential energy has been transferred to kinetic energy, which then pushes it up the next hill or loop. To find the potential energy of an object, you need the following formula. PE equals mgh. PE stands for potential energy, M stands for mass, G stands for gravity, and H stands for height. So if a rider on a roller coaster has a mass of 65 kilograms, leaves from point A at a height of 90 meters, and the force of gravity is 9.8 meters per second, our formula will be potential energy equals 65 times 9.8 times 90. If we first multiply mass times gravity, we get 65 times 9.8 equals 637. Then if we multiply 637 times the height, 90 meters, we get a result of potential energy equals 57,330 joules. Joules is the unit of energy. So we can say that at point A, our rider has a potential energy of 57,330 joules, and since they are not moving, the rider's kinetic energy is zero. Then after the rider travels to point B, their potential energy would now be zero because they are now at a height of zero and have no more potential energy. Since energy is never destroyed, just transferred, all of our potential energy is now transferred to kinetic energy. So at point B, we now have a potential energy of zero and a kinetic energy of 57,330 joules. So that's how you can use math to calculate the potential energy of a person on a roller coaster and how potential energy transfers to kinetic energy as they move. Thank you, now enjoy the ride.